a fiery streak from a distant star, or just a trick of the light? On October 7, 2025, the European Space Agency drops its first image of an interstellar comet, and the world ignites with controversy. While official channels offer blurry photos and technical excuses, NASA and other global agencies go completely silent. Amateur astronomers, however, start releasing sharper images from their own backyards, fueling speculation and outrage. What are we not being told? Let's explore this together. The blurry dot. It was supposed to be the space photo of the decade, but it looked like a mistake. At precisely 9:22 UTC on October 7, 2025, the European Space Agency released the first official image of 3I/ATLAS, captured by the CaSSIS camera on the ExoMars Trace Gas Orbiter. The public expected the stunning high-resolution detail we've come to associate with our Martian probes. What they received was a single, fuzzy, underwhelming pixel against the blackness of space. The comet, with an apparent magnitude of +19, was incredibly faint. Within an hour, this blurry dot became a global phenomenon for all the wrong reasons. The team behind the camera, led by its principal investigator, Nicholas Thomas, from the University of Bern, knew they were pushing their instrument to its absolute limits. CaSSIS was designed to look down at Mars from an altitude of 400 kilometers, not out into the deep void. They had performed a complex slew maneuver, pointing the entire 4,332-kilogram spacecraft at a target 30 million kilometers away that was over 10,000 times fainter than anything the camera was built for. The resulting image wasn't a failure, but a triumph of engineering that required stacking multiple exposures to even get a detection. The world, however, didn't see a technical miracle. It saw a smudge and immediately began asking what was being hidden from view.
Global outrage.
That blurry dot didn't just disappoint, it sparked a wave of digital fury. The initial letdown quickly escalated into genuine outrage as armchair analysts and amateur astronomers launched their own inquiries. Social media platforms were flooded with side-by-side comparisons, pitting the fuzzy official image against captures from backyard telescopes that appeared to show significantly more detail. The comment sections on agency posts turned into forums for accusations, with many users convinced that ESA was hiding something profound. This anger was magnified by the coordinated silence from other spacefaring nations. NASA, China's National Space Administration, and the UAE Space Agency, all operating orbiters around Mars, released nothing. No images, no press releases, no confirmations of their own observations. This collective silence felt deeply suspicious. People began to question why 3 independent, highly advanced space programs would all fail to get a clear shot. As astrophysicist Dr. Jesse Christensen of the NASA Exoplanet Science Institute often explains, maintaining public trust is paramount in science, and transparency is key. Every unanswered question only intensified the pressure, transforming a scientific observation into a full-blown public relations crisis.
Technical limits.
So, was this a cover-up, or just the hard reality of physics? The truth is, the blurry dot was inevitable, and the numbers prove it. Let me explain. The CaSSIS camera, developed by a Swiss-led consortium including scientist Gabriele Cremonese, is an imaging powerhouse when pointed at Mars. From its 400-kilometer orbit it achieves a stunning resolution of 4.5 meters per pixel. But 3I/ATLAS was 30 million kilometers away. At that vast distance, the camera's angular resolution of 11.36 microradians per pixel translates to a pixel scale of about 340 kilometers wide. The comet's nucleus, the solid object at its core, was estimated by astronomers to be only about 15 kilometers across at most. This means the entire comet was just 4.4% of the width of a single pixel on the detector. It's like trying to photograph a single human being standing in San Francisco using a cell phone camera in New York City. No matter how perfect your focus, the light from that object will never fill more than 1 pixel. The fuzzy dot wasn't a blurry image of the comet, it was the entire image of the comet. Its faint light smeared across one single sensor element. It was a technical ceiling, not a conspiracy. The camera could only give a fingerprint, not a portrait.
High-rise goes dark.
Just as the world needed its most powerful eye on Mars, the camera went dark. NASA's Mars Reconnaissance Orbiter is equipped with the High-Resolution Imaging Science Experiment, better known as HiRISE. Now this is a formidable telescopic camera, capable of spotting rovers and even their tired tracks on the Martian surface from orbit. It really represented the best chance for humanity to get a clear, detailed image of 3I/Atlas's core. But as the comet made its closest pass by Mars, HiRISE was effectively out of commission. The reason was a United States government shutdown that began on October 1, 2025, which froze the majority of NASA's day-to-day operations. All non-essential activities, including the uplinking of new commands to spacecraft and the public release of data, came to a halt. Astronomers, including the HiRISE camera's principal investigator, Dr. Alfred McEwen, could only watch the empty public archives, waiting for data that would never appear. The shutdown severed the command chain, freezing the entire data pipeline. HiRISE's forced inaction created a crucial information vacuum, leaving the narrative to be shaped by blurry images and a growing cloud of suspicion.
Radio silence.
NASA's silence was deafening, but they weren't the only ones who went quiet. Two other powerful orbiters were perfectly positioned to observe 3I/Atlas, China's Tianwen-1 and the United Arab Emirates HOPE mission. Both had been tracking the comet on its approach. Tianwen-1 carries a high-resolution camera capable of imaging Mars at a resolution of 0.5 meters. The HOPE orbiter, managed by project director Omran Sharaf, has the Emirates Exploration Imager, or EXI, a multi-band camera that could have provided crucial color data on the comet's coma. Yet, in the days following the ESA image release, neither the CNSA nor the UAESA published a single frame of data. No press releases, no technical updates, not even a statement confirming they had attempted an observation. This coordinated silence from three independent space powers was, for many, the most damning piece of evidence. Experts in international space policy, like Professor Svetla Ben-Itzhak, have noted that while agencies often keep data proprietary, such a complete information blackout on a major public interest event is highly unusual. Why would three nations, often competitors in space, all simultaneously withhold their data? The lack of information felt less like a coincidence and more like an unspoken agreement.
The image wars.
While the professional agencies remained silent, the amateur astronomy community took center stage, and, honestly, the internet became a battleground of images. In the days after ESA's underwhelming release, a torrent of pictures from backyard astronomers around the world began to circulate online. Using advanced techniques like stacking dozens of long exposure frames and applying AI-powered upscaling filters, these dedicated hobbyists produced images that seemed to reveal stunning details. One group, championed by popular online comet hunters, claimed to see a sharp nucleus and even faint jets of gas, arguing that their ground-based setups had outperformed billion-dollar orbital missions. However, professional astronomers, including Dr. Quanzi Ye from the University of Maryland, urged extreme caution. They countered by showing how aggressive digital processing can create convincing illusions. They explained that astronomical techniques like deconvolution, when pushed too far, can easily amplify background noise, turning random digital artifacts into what look like real structures. The debate quickly became highly technical, but the fundamental issue, as the professionals pointed out, was the inescapable limit of optical resolution.
Perseverance streak.
While the world looked to the orbiters, the most intriguing clue may have come from the Martian surface. At the Jet Propulsion Laboratory, Justin Mackey, the imaging scientist for the Perseverance rover, authorized a unique observation. The rover's navigation camera, or NavCam, was pointed toward the constellation Ophiuchus for 10 minutes, taking a sequence of exposures as 3I/Atlas was predicted to pass overhead. The raw frames revealed a single faint streak, just over a pixel wide, cutting diagonally across the image. The math was, well, tantalizing. At its known speed of 90 kilometers per second, the comet would have traveled exactly 54,000 kilometers during that 10-minute window, a distance that perfectly matched the streak's angular length if it was the result of motion blur. It seemed like confirmation, but rover operations lead Vandy Verma later noted a catch. The same streak could be produced by a much closer object, perhaps a 10-centimeter piece of orbital debris from a past mission like Mars Global Surveyor, moving at just 7 kilometers per second over a shorter exposure. Without the full FITS data headers to confirm the exact exposure timing, the streak remained a 54,000-kilometer question mark, the first piece of hard but ambiguous data in a sea of speculation.
Wow signal link.
Just when the story seemed like it couldn't get any more bizarre, it intersected with one of the greatest mysteries in the history of astronomy. As scientists plotted the precise trajectory of 3IATLAS, they uncovered a jaw-dropping coincidence. A line drawn from Perseverance rover's location in Jezero crater through the Comet on October 7th pointed almost directly to a region of the sky in the constellation Sagittarius. This patch of sky is famous for being the origin point of the WOW signal. Back in 1977, astronomer Jerry Amon detected an incredibly powerful 72-second radio burst from this exact direction, a signal that has never been explained or heard again. The comet's alignment with this historic anomaly was too perfect for the internet to ignore. Yet, despite the incredible coincidence, no major radio observatory, including the SETI Institute's Allen Telescope Array, under the guidance of senior astronomer Dr. Seth Shostak, announced a dedicated listening campaign on the 1420 MHz frequency of the original signal. The optical silence was now compounded by a profound radio silence, raising an unsettling question. With the geometry perfectly aligned, why did no one seem to be listening?
Approaching perihelion.
The mystery is reaching its peak, yet the main character is about to leave the stage. On October 29th, the enigmatic object known as 3IATLAS will reach perihelion, its closest approach to the Sun. It will plunge to a blistering distance of just 0.3 astronomical units, well inside the orbit of Mercury. For the following 38.5 hours, it will be lost in the intense solar glare, a period astronomers refer to as a blackout. This impending information vacuum is allowing every theory, from the mundane to the extraordinary, to flourish. Some astronomers predict the object might completely disintegrate under the intense solar radiation, which will heat its surface to over 400 degrees Celsius. But others, including those from Avi Loeb's Galileo project, wonder if this blackout could be used to hide something else, a deliberate maneuver. The Galileo project has put forth a compelling theory. An engineered course correction of even a few dozen meters per second, masked by the sun's gravity, would be definitive proof of an artificial origin. In anticipation of this, the project has announced a plan to use the Allen Telescope Array to listen for any telemetry pings the moment 3IATLAS is expected to re-emerge from behind the sun's limb. The world will have to wait. The approaching blackout is the ultimate cliffhanger in a story already short on answers.
The November tests.
As 3IATLAS rounds the sun and is expected to re-emerge into view in early November 2025, a global campaign of intense scientific scrutiny is set to kick off. Astronomers will then focus on a critical checklist of tests to determine what might have happened during its solar passage. First, they will meticulously analyze its light curve, the graph of its brightness over time, searching for any sudden surges or steep drop-offs that would signal it has broken apart. Second, they will use the new data to run hyper-precise orbital models, looking for any tiny, unexplained deviations from its predicted path. Such a change could be evidence of natural outgassing jets, or, as some are still theorizing, something far stranger. Hopes for an even better look are resting with ESA's Jupiter Icy Moons Explorer spacecraft, known as JUICE. Though it is on its long journey to Jupiter, it has a unique vantage point and a scheduled observation window. However, as confirmed by JUICE project scientist Dr. Olivier Wittas, the vast distance means that any data it collects won't reach Earth until deep into 2026. Until then, every new measurement from Earth will be another clue in a puzzle that has captivated the world. So, what is 3IATLAS? Is it a natural interstellar comet that arrived at the worst possible time, a victim of technical limits and bad timing? Or is the blurry dot, the synchronized silence, and the impossible coincidence of the WOW signal pointing to something more profound? The official story tells us of limitations, but the missing data tells a story of its own. We were given a front-row seat to one of the most significant astronomical events in human history, only to have the curtain drawn at the critical moment. The truth remains out there, hidden in the noise of a blurry image and the silence of the world's greatest observatories. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the mysteries of our universe. Until next time, keep looking up stellar tech.